Performing function operations. Here are your state standards, as always. And to be successful today, you need to be able to explain what it means to perform an arithmetic operation on two functions, find arithmetic combinations of two functions, and state the domain of an arithmetic combination of two functions, and evaluate an arithmetic combination of two functions for a given input. All right, so when it's talking about arithmetic operations, we're talking about addition, subtraction, multiplication, and division. So you can see right here, operations on functions. And this is the formal definition here, which it just shows you there's two different ways to write addition of functions. You can have f of g inside parentheses of x, and you can have f of x plus g of x. Same thing with subtraction, multiplication, and then division. Of course, with division, you can't divide by 0, so there will be some restrictions on the domain for division. But here are some examples of each one of these operations so that you can see that. And this is not very difficult lesson if you just kind of pay attention to what you're doing. Hopefully this will just be basically like combined in like terms when you add and subtract, multiply and divide different functions. Example 1, adding two functions. Let f of x equal 3 square roots of x and g of x equal negative 10 times the square root of x. Find f plus g of x and state the domain. Then evaluate f plus g of 4. All right, so we're going to start with f plus g of x. And remember that can also equal f of x plus g of x. And the reason I'm going to show you that is because we do have f of x and g of x separate. But remember over here, by definition, those two are equal. So it asks us to find f plus g of x. All right, so to do that, we're going to take f of x, which is 3 square roots of x, and then we're going to add that to negative 10 square roots of x. And again, we're just combining like terms. They both have a square root of x, so we have 3 plus negative 10, or negative 7 square roots of x. So f plus g of x equals negative 7 square roots of x. So that is taking care of the first part. So it says state the domain and then evaluate f plus g of 4. So let's first state the domain. So the domain is going to be all non-negative real numbers, and it's going to be non-negative because the x, the variable, is underneath the square root. And so since the domain consists of all negative or all non-negative real numbers for each of these, we combine those and it's going to be the same thing for the answer. So this will be basically all positive real numbers. All right, so domain, all positive reals. And the last part says evaluate f plus g of 4. So all we have to do is substitute 4 in for the variable. So I'm going to have f plus g of 4. And then my x becomes the 4. And we have negative 7 times the square root of 4. We know the square root of 4 is 2. So negative 7 times 2 is negative 14. So f plus g of 4 is negative 14. And if you were to graph negative 7 times the square root of x in your calculator, you would find 4 and negative 14 as an ordered pair, an xy value that falls on this curve. So 4 would be your x, negative 14 would be your y value. Again, that's an ordered pair that does fall on that curve. Example 2, subtracting two functions. Let f of x equal 3x cubed minus 2x squared plus 5 and g of x equal x cubed minus 3x squared plus 4x minus 2. Find f minus g of x and state the domain. Then evaluate f minus g of negative 2. All right, so similar to before, we do have to be a little bit more cautious with negatives though. So we're going to do f minus g of x. And we know that's the same as f of x minus g of x. Now, what you have to remember here is when you subtract g of x, you have to subtract all of g of x. So we're going to have 3x cubed minus 2x squared plus 5 minus, and we have to put g of x in parentheses to make sure we subtract each term correctly. So we're going to have x cubed minus 3x squared plus 4x minus 2, all in parentheses. All right, so we're going to bring down our f of x, so 3x cubed minus 2x squared plus 5, and then I'm going to distribute the negative to each term inside the parentheses. So negative times x cubed is negative x cubed. Negative times negative 3x squared is plus 3x squared. Negative times 4x is negative 4x. And negative times negative 2 is plus 2. So at that point, we can drop the parentheses because now we have distributed the negative, so we've subtracted all of g of x. Now we need to combine like terms. We're going to start with our highest exponent. So we have 3x cubed minus 1x cubed. 3 minus 1 is 2x cubed. And then we're going to do our x squareds. We've got negative 2x squared plus 3x squared. So that's 1x squared. And then we're going to go to our linear term. There's no linear term in f of x, so we're just going to bring down the negative 4x. And then our constant terms are 5 plus 2, which is 7. So this would be our function that represents f minus g of x. All right, also, f of x and g of x are both cubic functions, and we know that cubic functions have a domain of all real numbers. So we subtract it and we get another cubic function. And so the domain of this one would also be all real numbers. So we can put domain, all reals. Again, if you want to put negative infinity to positive infinity, that's the same thing. And now we need to evaluate f minus g of negative 2. Okay, so again, that means we're going to allow our x to be negative 2. So we're going to do 2 times negative 2 cubed plus negative 2 squared minus 4 times negative 2 plus 7. So I just took the function I have here, f minus g of x, and I'm going to substitute negative 2 in place of all of my x's. Now it is a good idea to just practice doing this in your calculator, so you should practice this as well. Typing these in, make sure that you get your exponents correctly. Make sure you put your x's in parentheses, but then when you raise this to a power, make sure you bring it back down. Sometimes people forget. It'll give you the wrong answer if you leave that all as an exponent. So let's see. I'm going to bring down, so I got negative 4 times negative 2, and then plus 7. All right, so if I type this in correctly, that should give me f minus g of negative 2. So f minus g of negative 2 equals 3. So again, if you were to graph this function here, 2x cubed plus x squared minus 4x plus 7, you would find negative 2, 3 would be an ordered pair that falls on that curve. So 3 would be your answer for f minus g of negative 2. Example 3, multiplying two functions. Let f of x equal x squared and g of x equal the square root of x. Find f times g of x and state the domain, then evaluate f of g of 9. So we're going to have f times g. So we've got f of x times g of x, and that's going to equal x squared times the square root of x. And if you want to write the square root of x as x to the 1/2 power, remember that's the same thing, then we have the same base. We can multiply exponents. Actually, the properties of exponents say same base. When you're multiplying, you add your exponents. So we have to have a common denominator. So we're going to have x2 can be written as 4 over 2. So we need a common denominator of 2. So hopefully you agree that 4 over 2 equals 2. All we're doing is rewriting this so it'll have a common denominator. And then x to the 1/2. So again, same base. We add exponents. 4 plus 1 is 5 over 2. And that would be our simplified expression here. So that would be f times g of x. Now, talking about the domain. Again, the domain of x squares would be all non-negative or all positive real numbers. And g of x would also have to be all non-negative or all positive real numbers as the square root of x. You've got a variable here underneath the square root. And if you graph each one of those, you know that x squared is above the x-axis here, and the square root starts at 0, but it is only in quadrant 1 when you graph that. So what does that mean for the domain of x to the 5/2 power? So the domain would remain the same. It would be all non-negative real numbers or all positive numbers. Let's see. Let's write this under here. So the domain, all positive reals. And I say all positive reals. That also includes 0. So positive real numbers and 0. You also could write that as x greater than or equal to 0. All right, then it says evaluate f times g of 9. So we want to do f times g of 9. So f times g was x to the 5/2 power. So we want to do 9 to the 5/2 power. And again, I would just use my calculator to evaluate this. I'm going to do 9 raised 2. And 5 is greater than 2, so we know this number is going to get 2.5 times larger. That's our exponent. So hit enter. And the answer to that is 243. And since we know that's got to get a lot larger, that does make sense. So 243. If for some reason you did not have a calculator, you could look at this as the square root of 9 raised to the 5th power. The square root of 9 is 3, and then you would have to calculate 3 to the 5th power, which is also 243.